Okay, we're in the final section of 15.2, and we will be completing truth tables. This is actually a continuation from the previous section where we were writing Boolean expressions. We started out with a circuit, we wrote a Boolean expression for it, and now we'll be completing a truth table. It may be helpful to build a truth table for an unfamiliar combinational logic circuit. It can also be a valuable troubleshooting tool. The Boolean expression must be stated in the correct form. If an expression is reduced to the point where there are no two variables joined by a vinculum, that means the not function, then there are only two types of expressions. They are either the min-term or the max-term forms. And so the min-term is often referred to as the sum of the products. And so the reason they say sum of the products is because AC, these would be products, and then the OR function here is the adding of them. So this is called sum of products. And then the max term is the product of the sum. So the product would be the multiplying together, but then we have the OR function. So they can look like this or like this. Now, when you construct truth tables, they often require the min-term type expression. So if you have a max term expression and you want to convert it to the min-term expression, you would use Rule 36. And if you look back in your rules of on Boolean, you can see that one. I'll just perform that function. If we had A or B ANDed with C or D, it would just be a matter of multiplying. This is something that you may have done in algebra, where you take A times C, A times D, and then B times C, B times D. They have some rules about that. AC plus AD, and then it would be plus BC plus BD. And this is equivalent to that. And then with this expression, you can complete truth tables. And so we have a couple of truth tables here. Here we have a three-variable truth table, and with three variables, if you take 2 and you have three variables, then there are 8 possibilities. And we start out with 0, 0, 0, and we count up to 1, 1, 1, which would be 7, and so that makes our 8 variables. So we would get a high when these conditions are met. And so A would be 1, B would be 1, and C would be 0. And so if we it might be helpful to turn that around. If we had 0, 1, 1, that would be in the form that we have it here. So let's see, 0, 1, 1. Okay, that's the number 3. We should have a high right here. And then this is going to be 0, 0, 0. That one's pretty straightforward. We should have a high right here. Now, in any other, all of these other potential inputs will result in a 0. We will have a high at these 2 points. Then here is another one. This one we have 4 possible variables. So in this case, we're going to have 2 to the 4th. So that would equate to 16 possibilities. And so that would go from 0 to 15. And these are all the possible inputs that we could have for a 4-variable digital circuit. And so the first one's real easy. It's going to be 0, 0, 0, 0. So that would be, we could get a 1 if we had all zeros input. And then we will get a high also if we have, let's see, this is going to be 0, 1, 0, 1. And if we flip it over to conform with that, we would have 1, 0, 1, 0. That is actually the number 10, 1, 0, 1, 0. So we should have a high right here. And then a C, 1, 0, so that would actually, there'd be a, with A and a C, if we had let's see, that would be 0, 1, 0, 1, is that right? Let's see, 0, 1. Okay, that would be the high 0, 1 right here. Isn't that it right there? There the C is a 1 and A is 1. Okay, that's it. And then the rest of these, this would be a 0, this would be a 0, and all of this would be a 0. So we should have a output at these 3 points, and these 3 points will conform with those 3. So the completing truth tables is fairly straightforward. Probably the hardest part, you got to draw the diagram here and just draw the correct number of possibilities. In this case we had 16, and this one was 8. If we only had 2, there would be 4. Then we looked at the min term and max term, and that completes our look at truth